All right, so very similar to yesterday, I'm not going to read the problem. I'm just going to kind of explain it, so I'd appreciate if you would pause the videos and read the questions and make sure you understand what we're talking about. But after you read this, you'll understand that with the current, so he's going up and back, this barge is. So, but each time they're still traveling 140 miles. So that's going to be 140 and 140 for a round trip total of 240. That's probably going to be important later on. And the time traveled, remember, this is distance equals rate times time. But you can manipulate that into say that time equals distance divided by rate. Or you can, so when we look over here, average speed, speed is how many miles per hour. So that's actually a distance. That's a different one. That's going to be my rate equals distance divided by time. All I'm doing is manipulating this so that either it says r by itself or t by itself. So that's how you come up with all three of these equations. You're kind of need to know those. And so what happens is for this miles per hour, we know that he's traveling, when he's with the current, he's going 15 miles an hour plus whatever the current speed is. Current meaning like the actual water. And when he's going against it, he's actually going 15 minus the current speed. And we know that the time traveled, if we go back up, it took him this many hours to complete the full session. And so, like we said, time traveled, time is going to equal how long did he spend going with the current, and how long did he spend going against the current? Like how much time did it take? It didn't take him 10 and 10, so because one time it was a little bit faster. So what you do is it's how far did he go? Remember, distance. Time traveled is distance divided by the rate. Well, in this one he's going 140, but his speed is with the current, so he gets that plus x. This time he's still going 140, but this time he's got going against it. So if we wanted to figure out how much time or how fast the current was going, if we add those together, we know that these together was a 20-hour trip. And so then again, you get this when you add those together. We know some restrictions happen. The rest of this right here, this math, should be very understandable to you because it's what we've done all year or all this chapter long. They have to get common denominators. Like I told you, the book likes to multiply by the least common denominator so the denominators cancel out. If you make common denominators and then forget about the denominator at the end like we've talked about, it's still going to get you the same stuff. And then based on that, that's going to be the real big, they just ask you these quick questions. What is the barge speed during the trip to the warehouse? Well, then you would take the 15 and add the current into it, which we just figured out the current speed, which was 3.87, and that gets you this number right here. So that's the average speed. Against the current, you're going to subtract that number, and so that's how they get there. How long does it take to get? So remember, how long time is a distance divided by a rate problem. So what they did is they filled in, we know the distance is 140. We know the rate, since it's going to the dock, we know that that was with the current, so they knew that the time, or the rate was 18.87, and when you divide that, that's what they got. It took him 7 hours and 42 minutes. They're going to do the opposite, where how long did it take to return? Well, now we're going against the current, so our speed is slowed down to 11 miles an hour. Again, it's still distance divided by rate, and that took him 12 hours. And if you add those two numbers together, these two right here, you will get the number 20, because that's how long it took to do round trip. All right, if you wanted to use the average speed, you would just take the speed of the barge going to there, take the speed of the barge going back, and divide by 2. Whenever you want the average of two things, you just add them together and divide by 2. Total time, we already talked about that. We did that. All right. Next type of problem. Again, please make sure you read through this. If we are going to calculate how much it costs, we have an initial cost of $2,000 because that's how much this refrigerator costs. So that's not going to change. Every time that if you bought this refrigerator, you've already spent $2,000. And then every year after that, it goes up by $46 because it costs $46 to run this. So what they did is after 1 year, it's $2,000. That's the rate, how much to buy the fridge, plus 46 times the number of years you own it, divided by however many years you have it. That will give you how much it costs you per year to run that or to buy that refrigerator. And so after a year, it costs you $2,046. But after I change that X to 5, it lowers it down to, it only cost me $446 to own that refrigerator. And after 10, it cost me $246. We already came up with B. If we want it to average out to less than 400, we would have to change this equation to an inequality instead of, we want it to be less than, so all we do is change it to less than 400. Cross multiply, you can still cross multiply. Put this over 1, they just cross multiplied. The only thing you have to remember, you treat an inequality just like you do an equation. The only thing is if you divide by a negative sign, which there's no negatives up here, so we don't have to worry about that. And we can see that she's going to have to, she can shop for a new television in about 6 years. All right. You could do this with a car, how much it costs you to buy a car, all these kinds of things you can figure out. So then she compares, she wants to see if I spend more money and get the energy efficient, or I spend, because when it's an energy, so to make this understand, an energy efficient refrigerator is going to cost more up front most of the time, unless you find a sale or whatever. But it's going to cost you less money to operate for the year, where this only took $46 to operate. Well, this one's not energy efficient, so it costs $60 per year. But this thing only cost her $1,900, whereas the other one cost her that initial $2,000. So she saves $100 right off the bat, but it costs her more. But if you look over 5 years, it costs her a whole $440 per year. When we go back up here, it costs her $446. So after 5 years, actually, this refrigerator costs her less, even though it's not as efficient to run per year. After 5 years, this one's cheaper. This one right here, after 10 years, it becomes, and how much did she spend total on this thing finally? She spent $2,200 after 5 years. How much has she spent total on this thing after 5 years? She spent $2,460. No, I'm sorry, 5 years. 2,230. So what's the difference between these two after 5 years? To buy the energy efficient one, she spent $30 more, because this is 2,200. That was 2,230. So to buy after 5 years, it's really only cost her $30 more. So to be honest, if it was me and I'm looking at these refrigerators, they cost about the same. They're not really saving me money by having one being efficient and one not being efficient. So if it was me, I would probably buy the energy efficient one, not because it's going to save me money, but just because it's going to use less energy, which is good for the overall environment, not necessarily for myself. Because if you look, after 10 years, it costs $250 to own this guy per year, and it costs $246. So you only saved $4 per year after 10 years by buying the efficient one. You only save $4 per year, which is a savings of $40. After 10 years, you save $40 by going with this energy efficient. So you're not really saving yourself any money. necessarily. Now, that's because these costs were so close. If you look, this one was only, the energy efficient one was only $100 more, and it really didn't save me much money. If you look, it was $46 to run this guy. It was $60 to run this guy. So to run this guy, I only have to spend $14 more. So it's not like a huge difference. I hope that's helping you understand this. I'm kind of going to go through, put the rest of this problem up again if you want to look. Right here, the book does something stupid to me. Right here, we do not have to break out the quadratic equation. I think that is really dumb. I do not want to do the quadratic equation unless I have to. These guys have a common denominator, or a common factor, and I can factor out, and I want this x normally to be positive, so I'm going to factor out a negative x, and when I do that, I am left with 14x, this changes the sign, minus 100, and I want to set that equal to 0. And so one of my answers is negative x equals 0, or, x equals 0 is one of my possible solutions. So if I don't buy any of them after 0 years, then I know that the average cost is going to be the same because I didn't spend any money. So after 0 years, which means I don't own either of them, I've spent the same. Well, duh, that makes sense. Or I can take 14x minus 100, set it equal to 0. To 0. I add 100, 14x equals 100, divide by 14, and x equals 7.14. Now again, it just shows you that you could use the quadratic formula if all else fails, and it still gets you the same answers. But it just seems like a lot more work. All right, get ready for that test. Hope you have a good night.